A drilling rig has many instruments and gauges. They help the driller and other crew members keep track of the drilling operation. Rig instruments vary from the most basic to sophisticated computers with video displays. Here, we'll cover the basics. The driller's console is the driller's workstation on the rig floor. It has several instruments and gauges. All of them help drillers track the drilling process and keep them informed of the situation. Indicators and gauges on the driller's console include the weight indicator, the pump rate indicator, mud pump pressure gauge, rotary tachometer, rotary torque gauge, tong torque gauge, mud return mud flow rate indicator, mud tank level indicator, and trip tank volume indicator. The weight indicator is the largest gauge on the driller's panel. It indicates the hook load and weight on the bit. The hook load is the total amount of weight hanging from the hook. Weight on the bit, or WOB, is the amount of weight put on the bit by the drill string. It is less than the hook load. The weight indicator is extremely sensitive to hook load changes. Drillers can use hook load changes to monitor the amount of drag or friction the well bore puts on the drill string when they move the pipe up or down. Or, because it is so precise, the driller can use it to monitor the operation of downhole tools requiring small variations in weight. The pump rate gauge shows the number of times one mud pump piston moves per minute. This console has two pump rate gauges because the rig has two mud pumps. The driller can determine the total volume of mud being pumped by multiplying the pump rate by the number of pistons in the pump times the amount of mud each piston pumps. The mud pump pressure gauge shows drillers the amount of pressure the pump is putting out. They monitor pump pressure from the standpipe to ensure that it is the correct amount needed to keep the hole clean and return cuttings back to the surface. The rotary tachometer shows the revolutions per minute, or RPM, of the rotary table or top drive unit. Drillers monitor rotary RPM because they need to know the rate the bit is turning. Different bits rotate at different RPMs. RPM ranges for a bit are specified by the manufacturer. Drillers use the rotary torque gauge to see how much twisting force, or torque, the rotary is applying to the drill string. Knowing rotary torque helps keep drillers from parting the drill string because of too much rotary torque. Parting the drill string in this manner is called twisting off. A tong torque gauge helps the driller and the rotary helpers make up the drill pipe and drill collars with the right amount of torque. Too little torque, or tightness in the connection, may leak or unscrew while drilling. Too much torque can damage or gall threads, which cause them to leak and eventually to come apart. Drillers use the mud return flow rate gauge as a relative indicator of how much drilling fluid is returning at the flow line. The sensor is mounted in the mud return line, the flow line. A paddle inside the return line moves as mud flows past it. As the paddle moves, it sends a signal to a readout panel mounted in the driller's control console panel. The driller sets the readout so that as long as return flow is normal with constant pump speed and output, no alarm sounds or lights up. However, when the return flow rate changes, increases or decreases, the paddle's motion also changes. This change in paddle motion sends a signal to the driller's readout and sounds or illuminates an alarm. A change in the return flow rate of the mud may indicate one of two things. If the flow rate decreases, mud may be being lost to a downhole formation. If the flow rate increases, formation fluids may have entered the hole and are forcing drilling mud out. So, a mud return flow rate indicator can help drillers detect kicks and loss of circulation. This mud tank has a special float in it. It goes up or down as the mud level in the tank rises or falls. Usually several mud tanks have floats in them. The floats send a signal to a digital totalizing panel mounted on the driller's console. This panel takes the tank level signals from all the floats in the tanks, totals them, and sends the information to the chart recorder next to the panel on the rig floor close to the driller's console. If the level of mud in the tanks falls and no one has removed mud from the tanks, then it is likely that mud is being lost to a downhole formation. If the level of mud in the tanks rises and no one has added mud to the system, then it's likely that formation fluids are flowing into the well. Thus, a mud tank level indicator is another tool to help the driller detect kicks and loss of circulation. A trip tank volume indicator helps the driller monitor the amount of mud being displaced by the tubulars or wire rope being run in and pulled out of the hole. Crew members calculate tubular displacement before each trip using tables from a handbook. Then, during a trip, they compare the calculated volumes to the actual displacement. Close monitoring of the trip tank during trips is crucial to proper well control. Such as the hook load, weight on bit, rate of penetration, torque, pump strokes, and pump pressure during drilling. It's usually located in the doghouse on the rig floor. The driller puts a chart onto the revolving drum. Several pins with ink in them trace records onto the chart. Drilling recorders may have from one to several pins, depending on how they're hooked up. The recorder gets signals from sensors mounted near the gauges that measure the drilling variables. For instance, a load cell on the deadline anchor senses hook load and weight on bit. Here's a photo of a drilling recorder. Note that it has a hinged plexiglass cover that drillers can raise to change the chart when necessary. Hydrogen sulfide, H2S, or sour gas, is the most poisonous gas encountered in drilling operations. It occurs worldwide in various concentrations associated with gas, oil, and water produced from wells. It is extremely toxic, explosive, and heavier than air. It is also colorless, so you cannot see it. In low concentrations, it smells like rotten eggs. But you cannot depend on your sense of smell to escape harm. H2S quickly deadens your ability to smell. Where H2S may be present, rigs are equipped with sensors, automatic monitors, and alarms. This is an audible and visual H2S alarm. The horn sounds a siren, while the light flashes brightly if they're activated by H2S sensors placed on the rig. This H2S sensor is placed near the mud tanks. Others may be at the bell nipple on the rig floor, shale shakers, flow line, rig accommodations air intake, and other places on the rig. When a sensor picks up H2S gas above a predetermined level, the monitor triggers both the visual and audible alarms. Upon hearing or seeing the alarm, crew members can take action to avoid injury or death. You will receive detailed H2S training if your rig is working in an area where H2S may be encountered.